want to make a 1x3x3 tensor. To find the information in the first, the second, and the third dimensions, I need to use indexing. So I'll be using these brackets right over here. Let's see what I get. In the first dimension, I'm only left with only one 3x3 matrix, which is just this. In the second dimension, I'm left with the individual vectors inside of my matrix, which would be this row right here, 1, 2, 3. And I want to find the individual scalar value inside of the vector. So on the second index, meaning the 3 here. I can also access all of the values inside of my tensor. So if I use x and index using the colon, that just prints out all of the values inside of the x tensor. Now, let's see here. I want to access all of the values in the first dimension, all of the values in the second dimension, meaning every vector, but I want to access the first index, the second index in each of my rows, meaning the 2, 5, and 6. So let's see if that's the case, and that's the case here. However, this seems to be in the second dimension. So this is still going to print out a matrix. It's not going to print out a vector, it's just a matrix. Now, let's see here. I want to access the first dimension, then the second dimension, so the first row here, and I want to access all of the values of my vector here, starting from 0, the 0th index, and it goes up to the before the second index, or it ends at the second index. So 1 and 2. Yep, 1 and 2. Now, I can turn NumPy arrays into tensors. So first let's import NumPy, then let's make a NumPy array, and we can turn it into a tensor by using from the NumPy method. Then I want to turn my NumPy tensor, just tensor. I want to turn my tensor into a NumPy array by using the function NumPy. So let's see here. I have an array here, and I have a tensor from here, and I have the array from what we had from before. Now, notice here that our tensor is going to be in float 64 when most of our calculations in PyTorch would be in float 32. So to change that, you would want to have to change the type of the tensor here and turn it into float 32. Now, random reproducibility. So let's use this example here. I have a random 2x3 matrix for A and B. Obviously, they're not going to be the same because they're always going to be random. Random, 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 random. You're never going to have them become the same at all. So sometimes we would want to perform repeatable experiments. So let's try and allow that to happen. I want to have a random seed. Let's call it 42. You can name it whatever you like. And I want to set my manual seed into that number 42 as well. So if I run a random tensor to make a 2x3 matrix, it will just create this. Now, every time that I reset every time that I call a new random, I want to reset my seed each time. So let's use torch.random, and let's call manual seed to set that equal to our random seed. Now I want to create my matrix, a 2x3 matrix. Let's see what we get. They're exactly the same. So my A matrix and my B matrix are going to produce the same values every time whenever I have my manual seed set to the same random number. Awesome. And lastly, ideally, you would want to use graphical processing units and tensor processing units for deep learning models and processing data. Nice.